Welcome, everybody. Tonight we are working on the Unit 7 exercises, and this focuses on file handling and exception handling. We're going to work through exercises 1, 2, 4, and 5, and I'm going to bring up the instructions here, and we'll get started on that. But first, a little bit of file management. What I'm going to do is in the folder where I store my work, and I'm going to bring that file dialog over. And I create folders for all the semesters where I teach this class. And I have one here for fall of 2025. And normally what I do is I just make one folder and then put all my work for that unit in that folder, right? And that's pretty normal. In this particular unit for each exercise, I'm going to create a subfolder. And as I explained before, the reason I'm doing this is to make sure that the exercises are kept separate from each other and the text files are kept separate from each other. The folder, I'm just calling it exercise 7.1, and then I'm going to go in there, and that's where I'm going to build my code, by the way. So as I go into Spider and get the program started, I'm going to do a save as and then call it exercise 7_1 and then put it in that spot that I just created. Right. And I know that we talked about file management early on, but it is important to know where your files are located. And you can see I have a very, at least I think, is an organized system, and you guys should try to have some sort of a system for yourself because it really does help quite a bit to make sense of what you're doing, frankly. So all right, let's go ahead and save that. I'm going to read the exercise description here, and then we'll get rolling on creating this. And I'm trying to also get my cheat sheets up on screen here, so I apologize. Normally I have all this stuff already queued up, and we are going to do it like straight out of the gate here. We're going to play with a couple of things just to see how they work. And then we're going to ramp up the code as we kind of move through it. So I just want you guys to be aware of that before I go into it. The directives that we have are pretty clear for this exercise. So let's just read those really quick. It says, write a program that carries out the following tasks, right? So if you notice these tasks here, they're a combination of different things, but it starts with open a file with the name hello text, right? So now that assumes, think about this, that we already have that file, okay? Store the message hello world in the file, close the file, open the same file again, read the message into a string variable, and then print it on the screen. So look, seemingly a pretty straightforward process here, right? Now, here it says open a file with the name hello text. So to me, that says that it already exists. And you guys might read that differently, but that's what it says to me. So we're going to try that. And so what I'm going to do, real frankly, is I'm going to pull my file folder back over to the screen here that I created. Remember, I made that folder for this exercise, which is right here. And then inside here, you can see my Python files already there. Now, inside of your operating system, and I know I talk about this file management stuff a lot, depending on what classes you take with me, especially if you're a web student, because it's super important for that field, I think. I'm using Windows 11, and you guys will notice that there is a view menu here. And then off to the right of that is this ... menu with the options menu. And I'm clicking on this for a reason, and that is to show you the folder options dialog box. This dialog box has 3 tabs up at the top, and if you click on view, it has a really important setting, I think, that all, in my opinion, IT professionals should trigger on, right? or off, technically. There's this little box right here, hide extensions for known file types. Right now, that is unchecked. So I can see the .py on my Python file, right? If you are not seeing yours, this switch is checked. So I'm going to check it, hit apply, and notice how that disappears. I'm going to argue that as a working IT professional, your file extension should always be visible. Mac, PC, Linux, whatever, always be visible. You need to know your exact file name that you're dealing with. And I'll demonstrate the why for this. I'm just going to move that off to the side and then come back to it. But inside this folder, I'm going to go ahead and right click and then choose new, or you can go up here to the menu, either way. And then I'm going to create a new text document, right? You notice what it does. When I can see the file extension, it allows me to name it a certain way. Now, they told me that I should open up a file called hello text, right? I typed it in, all lowercase. I'm pressing enter. It's locking it in. But if I were to trigger that setting that I just showed you, right? So hide extensions for known file types, click apply and then okay. Notice it gets rid of it. And then if I go here and then create another text document and I call it, whatever dot text and press enter, okay, there's my text file, right? Still a text file. But if I go back here now and flip it so that I can see the file extension, right? Look at what happens to it. I now have a double extension. And the reason I point this out is this is a top cause of errors for people first learning how to do this, right? Especially on Windows or a Mac, because both operating systems obscure the file extensions by default now. Why? Because normal humans don't care, basically. They don't care what the file extension is. As long as I can open it and it works and I can do whatever, they don't care, right? But an IT professional, you do that all the time. And Kathleen, the way that I get there is I go to the folder where I'm working, right? In Windows 11, there's this ... menu. If you're in Windows 10, by the way, they have a ribbon bar and they have, I think, view options or something like that. And in fact, on the ribbon bar, I think there's even a checkbox for file extensions. You can just check it on and off. That's Windows 10. Most of you should be on 11 at this point, I'm thinking. But otherwise, you click this, go to options, go to the view tab, and then right down here, hide extensions for known file types. You want that unchecked, right? This will propagate to your whole file system. All right, so now the file is created. I'm going to go ahead and double click it. Watch what happens. It'll open in the default program that handles text in my operating system. For Windows, it is Notepad, right? And indeed, the file is empty. It's got a name, it exists, but it contains no content. All right, so now I have a file there I can work with to open. All right, let's go back and start doing some coding now. And then I'm going to grab the instructions, of course, and I'm going to drop them here at the top. I'm going to do a little bit of zooming in the code panel, a little bit of zooming in the console here. And then I'm going to start running this. All right. So let's go ahead and think about a couple of things here. I can open up a file in a number of different ways, right? The general command for opening a file is open, and then you put in the file name, which is hello.txt, and then after the double quotes, a comma, and then I'm going to open it either in write mode or read mode, but we're going to open a file in write mode because we're going to add a message to it, so I would use the W switch for it. That's the general command. Now, when I do this, okay, this will run, but notice how it's giving me a little error here. This needs a place for the file to go when I open it. So we come up with a name. It can be anything you want it to be, but there are some conventions, right? So very commonly when we have an inbound file that we're just reading, we call it in file. And then when we have a file that we're writing, we often call it out file. And some people will abbreviate those. So for example, since I'm going to be outputting back to the file, I might call mine like out F. If you want to use the whole word out file, hey, whatever, that's on you. But this would open up the file named hello text in write mode, and then I would write a message to it. And so I'm going to do the commands that it's asking. So I'm going to take that out file, then use the write method that comes with Python as a default. And then inside the parentheses, I'm going to put in the text that it's asking for. I think this is verbatim how they're, whatever. And I'm saying hello world, but you can say hello, whatever you want, right? Then after you deal with the file, you take that out file and you run the close command. You got to type it correctly though. And that's just empty parentheses on that. That just closes the file, releases it back to the operating system. And then if we want to output that file, we'll put in a print command. And what I'm going to do with the print command is I'm going to move it way kind of down to the bottom here because we're going to use this through all the modifications I'm going to do in the program. I am going to use F strings here, and I'm going to kind of repeat back, some basic text. And I'm going to say the file contains and what does it contain? Well, the file basically. So I can just take whatever's in out file and print it back to the screen, right? And what might actually be good here is that I do a new line, right? And so I'm just kind of hacking this a little bit, right? I just want to show you how the technology works to start with. So let's just run this, right? It does assume this file exists in your folder, right? And let's run it. Okay. And it gave me a thing. It says the file contains IO text IO wrapper name hello text mode W encoding. Okay, so what did it do for me? It didn't. You guys notice it didn't give me the text of the file. It gave me information about the file I opened. Right. So this is not putting the text back on the screen. You guys feel me on this? But how do I know that the text made it into the file? Well, this is where you go back to your file system and open up hello text again and check it out. There it is, right? The text did make it into the file, but when I tried to like brute force print it, as a variable, this is just giving me the file information. It is not giving me the text in the file. Okay. So let's kind of ramp this up a little bit now. Let's like play with a couple of different things and see if we can get it to do the stuff that we're supposed to make it do. Some modifications you might want to make to this program is, for example, whatever message I want to put in the program, can I make a suggestion that we take this out of the write statement, and why don't we create a variable called message up here at the top and just put that into a variable. And then down here, I can just have it write the message, whatever the message is. Okay. I'm going to do the same thing with the file name. I'm going to set up a variable to hold the file name. And I know it's called hello text. It's not very challenging or anything like that, but we can do it. That should also be a string, right? Because file names are strings. So there's the opener and the closer. And then this can be replaced by the variable name, file name. We would still open it in write mode. But I'm going to show you like what would happen. Let's say I break the file. I don't have the right name. And I try to run this program. Watch what happens. Did that work? Okay, so your brain should say, yes, it worked, because I just wrote that file to my folder, and notice what it did. It created hello.tx, right? It did exactly what I told it to do, right? But we're writing it. What if I switch this to read, and then I like mess up the extension here a little bit, and now it's just going to try to read it in. Of course, the write command's not going to work, so I better comment that out right now, right? Because that's going to fail for sure. And I run it. What happens? Okay, well, now I'm throwing an error message, right? And I want you to listen to that terminology. When we get an error message, it's called throwing an error or throwing an exception, right? So it failed because this file doesn't exist. I can't read it in because it's not there. How can I read it in a file that's not there? Right. And so whenever we're interacting with the file system and it's not finding a file, that's throwing an exception. And that's what you're seeing on the screen here. It's giving you all this gobbledygook about what it's not finding. Okay. So how do we fix that issue? Right. Well, this is where we start re-engineering our program, and we start using try except blocks to handle our code. So this code here, which we know works, like at least these 3 lines, I'm going to place these in a try block. So I just go try and then a colon, and then I'm going to take this code and indent it all. I just press the tab key, by the way. I do see that I have a question. Kathleen, go ahead.
Could you show once again how you created that hello.txt file in your file system?
Yep, very simply, I just came here to the file folder.
Uh-huh.
You're on Windows, I assume?
Yes, that is correct.
Just right click, new text document.
Okay. I get a
Yeah,
new, let's see. Oh, on the top.
right there.
Oh,
There's
I see.
also there's a new button right here too. You can use that too.
Okay, I got
Right.
it. And then you
And
just call it hello. Is that what you
yeah,
just
you
call
name it whatever you want.
it? Okay.
Now, interestingly, most people don't create files with a right click, but it's a way you can do it.
Okay, got it. Thank you.
You're welcome. All right, so coming back here then, you see how I'm placing that code that I think should work in a try block, but just in case it fails for whatever reason, I put it in a try block. And then I'm going to add a print statement here as well. And last time I did this, I just had it do this, by the way. So if it works, it's going to open the file, write the message, close, and then give me a message on the screen that it worked. All right. But if it fails, we're going to use an except statement. And this would be of a type IO error, which is input output error for a file. And so you literally type this in there. And then we want to put something on the screen, but not make the program stop. And I'm just going to put up a message, error, file not found. Now, what some people do when they write exceptions, by the way, is they find the error codes, because normally, this will generate some sort of a numbered error code. So error number 2, no such file or directory. And you can actually pull this in, right, and drop it on the screen if you want. I don't know that it's particularly useful to most users. Techno geeks, maybe, right? But, if it's looking for this file not found. Now here, I'm going to have you think about this here for a second, though. If this is a write switch, will this try block ever fail? And the answer, by the way, is no, because we're creating the file with that command. So this will never fail. Regardless, I'm showing you the the process. But remember, this is just part of the process, and we're practicing try except statements. So, hey, let's just go ahead and do it. Now, because I'm telling it to create a file called hello text, when I test it, really, I should come up with a new file name, right, to make sure that it works, because I already have a hello text. So the one option would be is you can go back to your folder and just delete everything, right? That would be one approach. Or you can just change the file name and run it again. So that's what I'm going to do. Running it. All right. It's still giving me this weird output, and this is not ultimately what we're shooting for here, but at least it's showing me that something happened. And then I can go back to the file folder for now and just take a look and go, oh, okay, yeah, it worked. Hello there.txt now has hello world in it also. Thank you. Okay. So let's move on now to this part here. We did the first 3 steps. Now we're going to open the same file again, read the message into a string variable, and then print it. So now we already demonstrated that if we're reading files, that can fail because it might not find the file. So this is going to be an inbound file only, right? And and normally we call it in file, or some people just go INF, right? And that's going to use the open command. And this time we're going to still load the same file name. Okay, in this case, it's going to be hello there text, whatever. And then we're opening in read mode with an R. So if it doesn't find it, it might fail. Okay, now we're going to use our readline command, and I'm going to set up a variable called words, because I'm not very creative tonight. We're going to take that in file, and we're going to run the readline command on it, right? There's no stuff I'm throwing into the readline command. And what this will do, think about this. It opens the file with that name in read mode, stores it in this variable. Then we're taking that whole file and we're parsing it, right? So this word parse means to read through the file one line at a time and take each line of text and separate it into a Python list. That's what we're going to do. All right. So if you wanted, and I'm just doing this as an example, you don't have to do this part of it, but I could do hello world, and then so when I run it, it's going to add more text to it. Hello Milwaukee, then another new line. Hello Kenosha, another new line. Hello snowstorm. I was a little floored today when I drove down to Racine because we got no snow in Milwaukee, and I got to like Caledonia near the lake, and I was, oh my god, there was like really like serious snow down there. There were like cars plowed in and everything. I was kind of blown away. All right, so when I run this, it's going to recreate this file. And you know what? Let's just give it a different file name. Let's just make a whole bunch of files. Who cares, right? It's going to create hello to text with 4 lines of text. It'll close the file, tell me that it worked. Then it'll go to this block where it'll read it in, read one line at a time. And then what do we want to do? After we do processing with a file, we want to close it. So we'll issue the close command right here. Right? We'll output the file in a separate statement. The outputting never pretty much fails, by the way. We'll put in an except here. And once again, we'll use an IO error. And then we'll just give it an error message. And I think what I did last time is this. And notice I'm also putting in there error, file name not found, just in case it doesn't find it. Right? This is going to work. I can trigger it to trigger the exceptions though, right? So, so keep that in mind. Right. Now, let's go ahead and output. What are we going to output here in the curly brackets? Well, that file got placed here, right? We opened it, and then we want to do a read line. We know that if we did it, if we looked at what was in the in file, it's going to give us this. All right, great, thank you, but not very useful. But this read in the text one line at a time and puts it in this variable. So inside here, we're going to put words. All right, here comes the run, folks. Did this work correctly? Some of you are going to say, no, where's the other text? Right? Is that what your brains are saying? Okay, so let's just backtrack as to why that's happening. First, let's go look at the file itself, right? There's a hello to, and I open it up, but all the text is there. Okay, so this teaches you something really, truly about the read line command. The read line command just reads one line. It read the first line, and then it's like, I'm done. So how would I go ahead and read through all the lines? And that's where I'm going to take us back to our core shell here for just a second so you can see what the syntax is for doing that. Right. And basically what we do, oh, did I skip over it? Yeah, very much, very quickly. Right. Where basically we're going to run a loop to read in all the lines. I think we're going to probably do that in a later program, but I think you guys get the basic gist of it now in terms of how it works. So really we've accomplished the objective ultimately. The adding of all those extra lines, is something that I did as a hack, but I did want to prove to you that they did make it there, but our code's not allowing for it to read in each line separately. And if I wanted it to, I would add my for loop here. So I would say for word and you know what? I really don't want to do it. I'm kind of shooting myself in the foot for the next exercise. So let's just cap it here. Let's call this an exercise and that it worked. I would just say get rid of this stuff if you want to make it work. Play with different file names, but I think you guys get the general gist of this. Everybody's code work okay? All right. Why don't we do this? We're about an hour through class already. Let's take a 5-minute break and then we'll come back and code the next one. It's 8:53. Let's come back at 8:58. All right, folks, we'll see you in 5. All right, we're going to move on to exercise 7.2. And this program reads as follows. It says, write a program that reads a file containing text, read each line, and send it to the output file preceded by line numbers. So if the input file is Mary Had a Little Lamb, basically, the program, excuse me, produces the output file as follows. Notice what they're doing. It's like they're putting line numbers in front of it, like a /* line number with a space around the number, a space before the line of text. So we're reading in, adding text to it, and then putting it back in a file. We're going to prompt the user for the input and output file names. So the user is in control of it. Now, remember, when the user is in control of the program, you do run the risk of it crashing. Now, I'm going to go ahead and create a new file. When I do my save as here, I'm going to focus on file management first. I'm not going to put it in the same folder with exercise 7.1. I'm going to go up a level, create a new folder, and then call this folder exercise 7.2. You guys should do the same thing. And name the exercise 7_2. We'll zoom in a little bit here. I'm not going to copy over the instructions on this one. I think they're fairly clear. And in fact, I'm going to get rid of all this gobbledygook here. And now just thinking right off the top of my head, if I'm going to prompt the user for an input file name and an output file name, probably the first thing I'm going to do is prompt them. Whenever I'm interacting with the user, that's something that could fail in whatever kind of way, right? So I'm going to create a try except block right off the bat. And so I'm going to create a variable called input name, and that'll be the file that we're going to get as an input, right? And so I'm going to prompt them as follows. I'm going to say, enter the input file name. Okay, it'll capture that as text. That in and of itself could fail, right? Well, not in a lot of ways, but there's potential there, right? We're going to take that file name they just typed in, right? And we're going to feed it into an in file, meaning that we're just reading it, right? We're just going to read in the file. We're not going to write to it. We're going to write to a different file. So what file are we opening? Well, whatever the input name is. So that's the file name right there. And hopefully the user typed it in right? So that's the spot where it might fail. We're going to open it in read only mode. So we're just putting in the R switch here. All right. Next thing that we're going to do is we're going to ask the user to give us the output file name right away, right? And then we're going to open the file for writing. But think about that. That's a separate prompt and a separate action. So I'm actually going to put a try block inside of my try block. And this time I'm going to capture the output name of the file. And here's my prompt. I'm going to ask the user, enter the output. I can type it, file name. Right. Once again, that could fail with the next step here. So that's going to be an outbound file. So I'm going to call it outf. And we're going to use the open command. And we're going to feed in the output name that they gave us. And we're going to use the W switch so we can write to it. So this will create the file. I mean, technically, this should not fail. All right. The next thing that we have to do is when we read in the input file name, okay, this assumes we have an input file to give it, right? All right. So here's what I did last time, and I'm going to, somewhere here, I got a folder. I'm trying to find it, so bear with me. This is exercise 7.2. And what I'm going to do for you guys, so you don't have to create a file from scratch, I'm throwing one in the chat for you, but you don't have to use my file. You can use any file. If you want, in your file folder, you can find the right one here. Here we go. You could create a file, call it whatever you want, right? If you want to have it, Mary Had a Little Lamb, and put whatever stuff you want inside of it, you can just go through this whole process, mind you, right? Like you could do this. Mary Lamb, for example, right? And then I could open that file with my text editor and type in Mary had a little lamb. Her fleece was white as snow, and everywhere that Mary went, the lamb was sure to go. And I'm not even being very careful about this, how I'm typing it. I'm going to save that. So I could use this file if I wanted. But the file that I threw in the chat, which I'm going to copy now into my folder, is got the first few lines of a Beatles song, which I prefer over Mary Had a Little Lamb. So it could be really any poetry or text or whatever you want. You know, that's on you. So I'm going to use this one. I do want you guys to notice that this one's called input.bb or -bb.text. right? And I'm trying to copy it back to its source location here as I deleted it from there. So I remember that file name, right? And my naming convention here, whenever I use spaces, I'm using a dash, right? You don't have to. That's just my naming convention. And I like all lowercase generally, for naming files. All right. So here I might type my input file name. Here I type my output file name. I don't need to pre-create that because the program is going to do it for me as we're kind of moving through. Now, when we read this stuff in, we're going to start looping through the data in the file and processing each line of text and then adding text to the beginning of it. And what are we adding to the beginning of it? A line number, right? So I'm going to set up a variable here called number to give me the starting number, right? Which is going to be 1. So I'm just calling it number. Then I'm going to go into a for loop. And very typical, like for each line in the in file, so the inbound file, I'm going to go line by line, right? For loops will do this automatically, by the way, which is why we like to use it with them. I'm going to then write to the out file. So I'm going to do out file dot write, and then a set of parentheses. And then I'm going to figure out, what am I writing? Okay, one thing I can do is I can just take the line of text that we're currently looking at in the file and write it into the out file. But I want to add stuff to it. So at the start of the line, I'm going to do this. I'm going to use a double quote, and then the characters they used was /* and a space. So / and a space, close the double quotes. Then I'm going to concatenate to it the number converted to a string. And the reason I'm doing this is because it makes the concatenation easier, by the way. And then it's going to go space * /. So here's double quotes, space * /, close the double quotes. And then we're going to concatenate line to it. Now, I could also do this with F strings, right? So if I was to do this with F strings, I'd put an F here at the beginning. I would get rid of the concatenation marks and the internal double quotes, right? And the reason I'm doing this is to kind of give you the mindset that, yeah, you can engineer it this way if you wish. And I would say this is probably the better way to do it. But some of you might do it that way, especially if you're used to other programming languages. And then this double quote and this plus sign would move. This would get wrapped with curly brackets. And then we put a closing double quote there. Okay, so this will put the original line back on the screen. This will add / space, the number converted to a string, space * / a space, and then the line that was the original line. That's what it's going to write. And then every time we go through the loop, think about this, we want that number to increment by 1. So it'll start counting up. After it reads through the whole file, we'll do an in file close. We'll do an out file close. Right. And, and I always like throwing this little message here. Don't forget to close your files, especially the ones you're writing to. Okay. And then, like I did the first time, and this is inside the try block, I'm going to put a little message on the screen just so I know that something happened, right? Because really it's happening in a file. I'm not seeing anything happen. So I'm just putting a message on the screen. Hey, something happened. All right. Now we're going to backspace now with one line down, and I'm going to backspace out one indent. And then I'm going to put in an accept statement. And notice I'm not declaring what type it is, just a generic accept. And so if this fails for any reason, meaning if this code here fails for any reason, I'm just going to put this message on the screen that hopefully makes sense for what's going on, which is, as you can see there, sorry, that won't work because your input file did not exist. That would be the only thing that would trigger it. The writing won't trigger it. The reading would trigger it. Then on the outer try block, I'm going to do an accept again, except this will be an IO error. And truly, this one is too, but whatever. I'm just trying to show you that you don't have to do it that way. And then the error that would go at the outer one, and remember, the outer one's handling this mostly, and all of that as well. And then my error message on that one is this. Not finding the input file name. So basically the same message. Now, nesting the one try accept inside the other, is that absolutely necessary? I'm going to say probably not, right? But, last time I coded this with a class and we kind of went through the mechanics of it, this is what we settled on. So this is the example I'm giving you here tonight. I'm going to go ahead and run this. All right, so I have to enter the input file name. I could give them the wrong name. Oops. Intentionally. Right, there you go. So it didn't crash, it ran, it gave me an error message. All right, let's try it again. And you guys remember what I called it? I called it input dash BB for Blackbird, by the way, if you're wondering, dot text. Okay. Now it wants the output file name. How about I call it output dash BB dot txt. Let's enter. And now it gave me a message. It got to here, which means all of this try code worked. Now the only proof is to see what's in the file, right? So let's go take a look, right? We will get to the point where we're just printing it back. But if I go to my folder here, now you can see it was just created 9:14 p.m. It's 9:15. I'm going to double click it, and there it is with the lines and appended text, right? The original, the revised version. So we opened it, we added information, saved it to a new file, and we can see it. All right, let's move on to the next exercise. Next exercise is 7.4. And 7.4 says, write a program that reads a file containing 2 columns of floating point numbers, prompt the user for the file name, print the average of each column. Uh-oh, it sounds like math. And how do we handle a file that's got columns? All right. And so this is kind of an interesting exercise, by the way. As we get started on this one, what I will tell you is that it is important to have a file, and I'm opening the file right now. This is one of the files I have, and I have 2 different versions. So I have input 1 and input 2, and this is the original, by the way, input 1. So what I'm going to do is I'm going to throw input 1 in the chat for you. Here it comes, and then just plain input in the chat for you. And the reason I'm doing this is that way we're using the same numbers. But what I also want to show you with these input files, these are text files that are built with text, right? And I want you to notice as you see my cursor as I move it around the screen. And then when I go from 1 to 1.5, it jumps. So these are not spaces in between here. This is a tab stop. So this is what we call a tab delimited file. The information is separated by tabs. And I have one column of integers and another column of floating point numbers. And the directive is, mind you, to read a file containing two columns of numbers and then prompt the user for the file name, print the average of each column. All right, so I not only have to read the stuff in, but I have to separate it into columns in the process of reading it and do math with it all at the same time, right? Kind of an intense process. We'll start with this one, which is input 1 first, and then we'll use the regular input file, which has 3 columns of numbers, and I'll show you how you can ramp up your code to accommodate for both, right? So back over to Spyder here. I am going to do a little file management and like confusing all my file windows here, but I'm going to go up one level, create another new folder. This is going to be exercise 7.4. Those files that I gave you in the chat, you should put in that folder. Okay, it looks like my VPN connection just dropped. I don't think that should be an issue. I'm assuming you guys can all still hear me okay, right? Yes, no, maybe. All right. So I'm dropping those files in there so I have them both accessible. Next thing I'm going to do is I'm going to come to Spyder and create a new file. So let's do a save as. So it's going to be exercise 7_4. Oh, and I put it in the wrong spot. Did you guys catch that? Yeah. I'm gonna close it, and instead of recreate it, I'm just gonna handle it with file management. If I can find my folder, there it is. So I put it here, and I don't want it there, so I'm gonna cut, and then I'm gonna go here and paste. Right, and then I'm gonna open it in Spyder. There we go. Much better. All right. First things first. Let's open up the file in read mode because we're just going to read in the information, right? We're not going to change the information. We're reading it in and processing the data, right? That's what we're doing. So we'll set up a try block and we'll do a variable for the file name, which I'm going to prompt the user for. And I'm just going to say, enter the input file name. Captured as text. We'll store that in an in file, and we'll use the open command to open the file name designated in read-only mode. So with the R switch. We'll set up an exception right here, and we'll just do a simple exception. And say something simple like print. How about error in all caps and something file not found. It's pretty serious, right? Not finding your file. Now we'll start a separate try block. And then we're going to basically here set up variables to do the calculation. So I'm going to set up the thing about this. If I'm going to do averages of 2 columns of numbers, how do you do that? You add the columns together, right? So you get a total, and then you divide by the number of columns or number of entries that you have. By looking at the input file, I notice that I have a synchronous number of entries, right? So I'm going to set up another variable called count that's going to keep track of which line we're on, basically, or basically counting how many pieces of information we're processing is a better way to say it. Right. Next, I'm going to go ahead and I'm going to read in the lines from the file and do the math. Well, try to do the math. All right, so let's do this part. This is the first time we're going to be using one of our commands, which is the split command. And I didn't even think about this, but like the file name here, one thing that I could have done with it, and I'm just throwing this in as an extra tidbit, is I could take the file name, and if you want like a demonstration of the strip command, I could do this to it, which just in case I type an extra space at the end, this would get rid of it. Right. So if you want to throw that in, you can. I would call that, optional. All right. But down here, let's start our for loop. So now I'm going to say for each line in my in file, I'm going to do the following. I'm going to set up a variable called parts. And what this is going to do is we're going to take each line of text and I'm going to run the split function on it. That breaks the lines of text, the line I just read in, into separate words and puts it in a Python list, right? So Mary had a little lamb. Mary had a little lamb. That's 5 words. It would create a Python list of size 5 with 5 separate storage spots with those words individually stored and the spaces omitted. Then I want you to think about this, how this is going to operate. When I read in a line of text, it's going to read in this, then it's going to detect the tab. It'll read that as a natural break. So this will go into one Python list location. This will go into the second Python list location. I don't want to add those two together, but every time I hit the first position, which is position 0, and then the second position, which is position 1, I should be keeping track of the total, right, of each one of those. So I can do math with it right away, right? So right here, after I split it apart, I'll take my total 1, right? And I will actually not equals, but plus equals to the total. Whatever is in parts position 0, but I want to treat it as a floating point number. So I'm going to do a caster conversion. So I'm going to convert it to a floating point number and then store it in total. And you know what? I'm going to do that with the first column. And then I'm also going to do that with the second column. I just need to adjust my values. So I'm going to make that a 2. And I'm going to make that a 1. Then I'm going to increment my counter by 1 for the next iteration to keep track of how many numbers I have, right? We started with 0. So I just took 2 numbers, added them in. Okay, 1, right? We'll do it again. It'll go down the list. So what it's going to do mechanically is this. All right. That goes to total 1. That goes to total 2. Total 1, total 2. But it's total 1, total 2, 1. Total 1, total 2, 2. Total, etc. It's going to do that process. Then when we get to the end, we can do the math to figure out the average of each column because they'll be stored separately. And I think it's really clever that you can do that. So this is all the reading that we need here for the for statement. And I'm going to come back one indent level, and then I'm going to close my in file right there. Next thing that we want to do is we want to calculate the average, right? That's actually pretty simple to do. I'm just going to drop this in all at once. Since we've already got the totals, we just take the total for each, divide it by the count, and then we'll come up with 2 average amounts, average 1 and average 2. Then we'll do a little bit of output, right? Which I call display the results. And then I want you to notice too that like a lot of what's happening in this program is all inside of a try block, right? All right. Now we'll do our outputs. So we'll just concoct a few statements here. So we'll do a print with an F string. And then inside there, we're going to say total 1 equals. And the reason I'm doing this is I want to see the math, basically. total 1. And then if I'm doing that once, then I can do that again. So copy paste. And this will be total 2. Heck, let's just go ahead and display the count as well. This helps us to verify our math is really correct, and that's really the only reason why I'm doing it. I'll just say count equals count. And then let's put the information on the screen as to what the actual results were. So once again, an F string, and we'll say the first column average is, and then we'll just put the number up on the screen. So it's a AVG1. And then if you wish, you could format it if you want. You could do like dot, I don't know how much precision we want, like 4F might be good, 4 floating point numbers. And then of course you can copy that and you can say second column average is average 2 with a little formatting. And then we're kind of done, right? So then I'll put in my except to close it out just in case something fails. And then this is the snarky message I put in last time. You know, it said epic fail, your program stinks. Let's go ahead and try to run this and see what happens. All right, so I'm going to run this code. I'm going to save it. You need to remember that we're going to try this with input1.txt first. So in other words, this file first, which is the one with 2 columns. Okay, so let's just go ahead and do that. Here's the run. Oh, and I got, oh yeah, that it doesn't like that syntax. What is the correct syntax for that? Is it a colon? I'm like failing with my formatting commands here. Let's see if it, all right, apparently that's correct. So switch that to a colon, folks. So the input file name is input1.txt. Okay. So it says the total is 21 for the first column, 15.7 for the second column. There's a count of 6, and it gives me an average. How do I know that's right? Well, the only way you really know that's right is to pull out your calculator, you know, and do the math. I know this is correct because I've done this math before, and I wrote the results in my comments of my previous version of the program. So that's giving us the correct things. Now, if you want to use the other file where I add a third column of numbers, so you would use input.txt. We could do that, but we would have to ramp up our program a little bit. So one thing we would do is we would add another total column. So I'll add a total 3. In the math, we'll copy one of these lines here and name it total 3. And that'll increment to position 2. And then we'll have another average to calculate. We'll call that average 3. Then, of course, this would also ramp up a little bit. But notice how easy it is to change it. Like once you have it working, it's not very hard, right? You know, if you have something that works, adjusting it just kind of becomes a thing in the aftermath. I'm not sure my formatting command is working as I'm intending here. And maybe somebody can look up the correct syntax for me and I'll fix it. Saving, running it again. This time I'm going to input the input file. That's got 3 columns of numbers. And there you go. And it looks like the formatting is like not really, the number formatting is not working at all. So I'm going to call this superfluous right now. So I'll have to fix that later. So let's call this one done, folks. Let's move on to the last exercise here. We have plenty of time to get this one done. And I might end up doing a couple of versions of it. We'll see as we're kind of working on it. Okay, let's read the instructions first. It says write a program, find py, that searches all the files specified on the command line. I'm reading the wrong one. Yeah, I am. All right, the one above it. Write a program that asks the user for a file name and then prints the number of characters, words, and lines in that file. Okay, interesting. All right. One thing that I often do with my students is before I do this exercise, it's like this is a really common programming task actually they're asking us to do. Like right now I'm looking at the instructions for this inside of Microsoft Word, and I don't know if you guys ever noticed this about Microsoft Word, but down here in this, I guess status bar at the bottom, there's this little box that if I click on it brings up this panel that basically does exactly what we're about to write, you know, where it looks at a document, tells you how many pages, words, characters with no spaces, characters with spaces, paragraphs, lines, et cetera, right? And look at what we're trying to write: characters, words, and lines in the file. Okay. And notice Word does this automatically. So they have this code built into Microsoft Word. Why do you want to know that? Because maybe your teacher said, hey, I want a 3-page document with 50 lines and 500 words, or something, minimum, that type of thing. So that's what we're basically going to build here. And we're going to do this kind of step by step, but we will need to have some files to work with once again to make this kind of a feasible activity. What I did, and I'm dropping it in the chat right now, is I went out and grabbed this file that I just shared with you. And right now I'm going to add it to a fresh folder. So I'm like trying to do file management here in the background. So once again, I'm going to go up a level, create a new folder. This is exercise 7.5. And I'm going to paste that file in there. And if you guys haven't guessed already, this is the complete words for the song Blackbird by the Beatles. Right. So basically, because there's just more words, more lines, and all that. And if I wanted, right, I can go here to Microsoft Word, create a new blank document, take the text from that file, Control A to copy, Control C to, or Control A to select all, Control C to copy, and then I'm going to paste it into Word. And then I want you to notice that Word automatically tracks it. So 1 page, 124 words, 630 characters with spaces, and 18 lines, right? So this gives me a point of reference to make sure that my code's working correctly without having to manually count everything, right? So, and that's kind of why I'm showing it. All right. Now we're going to go ahead and create a new program, do our save as, and then navigate to the right folder. And we're going to call this exercise 7 underscore, 5. And we're saving. Zooming in, getting rid of the junk at the top. And once again, we're going to start with a try block on this. Okay. Now, I'm going to ask the user to enter a file name. And I'm also thinking about this. I'm going to be counting stuff, right? I'm going to count the characters, the words, and the lines, right? So I'm gonna create variables for those things, and I can do that just about anywhere in the program. I'm gonna actually do it right here at the top. right? So I'm just going to create the variables now and then forget about it, right? Now, okay, you could argue, and I'm just going to throw it out there. Well, those variables aren't really going to fail at any point. Do they really need to be in a try block? Like, you know what? Let's pull them out of there. I'm going to cut them and I'm going to put them up here. Okay. Then I'm going to set up kind of what we've been doing all along, a file name I'm going to capture, and I'm going to prompt the user and I'm going to say, enter the input file name. Right? We know what that is because we put it in the folder. Now, if you don't like the file that I provided, go out there and find your own lyrics or poetry or whatever. Go, lyrics.com or whatever is out there. Uh, Copy paste it, create a text file out of it, put it in your folder, and you can use those words instead. You don't have to use the words that I'm using. Right. Now, here's kind of a weird thing, right? When you're interfacing with a user, and we're putting a bunch of tools in our arsenal now that and you guys might not be thinking about this, but like, what if like somebody uses your program and it's like, oh shoot, I just misspelled it. Oh, now the program's done. I got to relaunch the program. Right. What if we give the user like a few chances to type the file name in correctly? How about that for a thought? So right here underneath this statement, I'm going to set up a while loop, and I'm going to say while the file name is not blank and the count is less than 3. All right, well, I haven't set up a count, but I'm going to give them 3 chances is what I'm going to do. So right here, I'm going to create a count variable. I'm going to set it to 0. Every time they attempt to type in the file name, I'm going to keep track of it. If they get it right, okay, no problem. But if they get it wrong, I'm going to give them 3 chances, and then the program is going to stop, right? 3 times, and you're done, basically. All right. So if they didn't type the file in, right? And basically, if they do it wrong, what am I going to put up on the screen if they do it wrong? I'm just going to say print file not found. Sounds pretty serious, right? Yeah, it is. Right. Then I'm going to prompt them again. In fact, I can just, instead of typing it, being kind of silly here, I can just copy the prompt again. So this is your next attempt, basically. And you know what? We're going to try to capture it again, but hopefully it worked. And then we'll add 1 to the count. We're going to plus equals 1. It doesn't work. So they type in a blank or the file's not found, right? It's going to keep asking. It'll do it 3 times and then it'll jump up. From there, I'm going to come back 1 indent and I'm going to say, now we're going to put it in our in file. We're going to open that file name and we're going to open it in read only mode. We don't need to change the file. We just want it inbound. And that's the reason why it might fail. And then what I did last time is I did this. I just gave them a message if it worked, right? Let them know that it worked, right? File successfully loaded, right? And then I'm not sure. It looks like I put in 2 messages last time for it. File successfully loaded. This is giving me an error. I'm trying to figure out why is it. Oh, it's giving me an error because I have not done the accept block yet. Why don't we do that? Let's do that right now to get rid of that error. So let's just go accept. This is an input output error. And then I'm just going to put in an error message, right? If it all fails, ultimately. Right. But I'm still going to keep typing stuff here, by the way. All right. We have our variables to store the words, characters, and lines. Now we need to read through the file line by line and process it. So I'm going to say for each line in the in file, we're going to do the following. Right. Every time I load up a line, I'm going to set up a variable for lines, which I have above. I'm going to add 1 to the lines. Okay, we went through a line, add 1 to it. For the tracking the characters, this is kind of a weird one. but I'm going to plus equals to this, the length of the line. Think about this. If I have 20 characters of text in a line of text, including spaces, right? So I count the characters. I just look at the length of it. It starts at position 0, but goes to position whatever. But the length is a finite number. So it'll tell me how many characters and spaces there are in a line just by running the length command, right? So pretty clever, actually. If I want to know how many words are in the line, I just use the split command, right? So I'll split the word. So I'll basically do this line dot split, splits it into separate words. But I'm not really interested in the words. I'm interested in how many words there are. So I'm going to put all of that inside of a length function like this. Okay, so it's going to loop through. Every time it loops through, it counts a line. Every time we load up a line, we're going to look at the length of the line and store it. And then every time we go through, we'll split up the words, count how long that list becomes, and that'll tell us the number of words in each line. We're then done processing the file, so we'll do an in file close. Close your file, folks. And then I did this output to kind of cap it. So here's my output to finish off the program. And notice I try to make it all align real nicely. And I didn't use F string here. I used the old school argument approach, which works just fine. So I'm going to go ahead and run this. All right, here's save. And then what was my file called? Blackbird.txt. Here's the run. And I'm going to say blackbird.txt. File successfully loaded. Okay, the file contains 647 characters, 124 words, and 18 lines. And if you go back and look at Microsoft Word, I think that's basically what we came up with over in Microsoft Word. So it is working. One real interesting little revision I did last time to this, which is kind of fun, by the way. What if you wanted to run this? Okay, so I ran it once and fed one file into it, right? What if I wanted to run it more? You know, and this is something you might ask yourself. So I'm going to bring my cheat sheets over here, and I just want to show you what I did. If you wanted to keep this program running, one approach would be, right, and you know, the layout's a little bit different, but essentially the same code. Notice that grab the file name, and then here's the alteration. I did the with command, right? And I did all the processing inside the with command, right? So I told them it was successfully loaded. I set up my variables. I went through line by line. I closed my file. And actually, this is not necessary with the with command, right? So I can get rid of that. And then I did my output. And then if it worked right, I would break out of the loop. But the whole program exists inside of a while loop. So I can let people do it over and over and over again. And if they fail multiple times, you know, I'll give them 3 attempts basically, and then they're out. But this is a modified version if you guys want to play with it. Right? I'll just leave it on the screen for a second. The first version that I wrote is what I'll accept as a correct answer. This would also be correct as well. And, you know, and if you want, here's a side by side of the code. You know, not quite side by side, but close. There we go. So you could use either approach. I'm not going to run the second approach. I just wanted to demonstrate to you. We do have like these tools in our arsenal now. So we have try blocks with except clauses. We have loops, so we can run things over and over again if we wish. And I don't always do this for our exercises because we're usually trying to accomplish a task. But I'm just trying to give you the idea that if you want to do that, it is completely possible to do it and do it pretty effectively with not really a lot of code. I also did want to show you an example of the with statement. And once again, if you use the with statement, you really don't need this little piece, right? And that's my error. I should probably do this and then say, oops, here, not needed. Basically. All right, folks, that wraps all the exercises here for this unit. So I'm going to stop the recording here.